For our last section in Unit 8, we're going to be looking at complex numbers in the imaginary number system. And we're going to be looking at how to add, subtract, multiply, and divide them as well. An imaginary number, I, is the number that forms from a negative under a square root. And you learned this in Algebra 2, so it shouldn't be new information. Basically, if you have a square root with a negative under, it's not a real number, which is what a couple chapters ago we focused on. It's not a real number, it's an imaginary number. And so the way that you write this is you actually just pull the negative sign out, it becomes an I, and then the number, or in this case the R, stays under the square root. Now this can also happen if you have square roots that need to be simplified. For example, square root of 12 can be simplified. So the negative sign comes out and becomes an I, and then you would go ahead and focus on reducing the square root of 12. The square root of 12 is 2 square root 3. So the 2 would come out with the I, and then the root 3 would go right back under, making it 2I root 3. And that's how you simplify i's or pull them out of square root. Now from this theorem, if I equals the square root of negative 1, if we square both sides, we end up with I squared equals negative 1. And that's where that comes from. So if you remember from Algebra 2, constantly changing I squareds to negative 1, that's where it comes from. I squared equals negative 1 due to this theorem right up here. And we're going to be focusing on that today as well. The first thing I want to look at is adding and subtracting i's. So this is the first problem I want you to look at. It looks like we're adding the complex number 8 minus I to the complex number 5 plus 4I. Now I really want you to think of that I just like it's an x or a like term, because you always treat these i's just like you're putting like terms together. So literally in this case, you would put the 8 plus the 5, which would be 13, and then you'd put the negative I and the 3 and the 4I together, getting you 3I, and your answer would be 13 plus 3I, the complex number 13 plus 3I. You do need to write it in this order, with the real number first, the imaginary number second. Now let's go ahead and look at a little bit more complicated problem, something like this. In this particular problem, I'm multiplying 4i times a quantity. So I'm going to take this 4i and multiply it in exactly like I would if it was an x. Once again, I really just want you to look at this like it's an x. So 4i times negative 6 is negative 24i. And then 4i times a positive I is a positive 4i squared, exactly like you would do if it was x's. I times I is I squared. Now, I squared, as we know from before, is actually negative 1. So instead of 4 times I squared, this is actually 4 times negative 1. So I could rewrite this problem, negative 24i minus 4. 4 times negative 1 is negative 4. And then, of course, I would want to switch the order of this because we want our real number to come first and our imaginary number to come last, making my complex number negative 4 minus 24i. Now, I want you to look at these two problems, and I'm actually going to solve them two different ways. One is correct and one is incorrect. So I wanted to make sure you know the correct way to do it. In this first problem up here, I'm actually going to pull out the i's first. So I'm going to make this I root 3 times, and then I'm going to make this I root 7. After I've got I root 3 times I root 7, I'm going to go ahead and multiply. And remember, we multiply outside times outside and inside times inside. So I times I is going to be I squared. 3 times 7 is going to be 21. So what I've got is I squared root 21. I squared becomes a negative 1. So what I've really got is negative 1 root 21 for the solution of my first problem. For my second problem, I am not going to pull the i's out first. I'm actually going to multiply them as is. Negative 3 times negative 7, is a positive 21, leaving me an answer of root 21. Which one's correct is the question. This one actually is. This top one is. It is imperative that you pull your i's first before you multiply or divide. Definitely pull those i's first. It will create an incorrect answer if you don't. For our next problem, we're going to look at division. Now, the same way that we can't leave roots in the denominator of a fraction, we can't leave i's in the denominator of a fraction. So as you're looking at this problem, you'll notice there's an I in the denominator and we need to get rid of it. And we're going to do it in a similar fashion as we did it with the radicals. So if it's a monomial, not a quantity, you just multiply by what you want to get rid of. I want to get rid of the 4i in the bottom. I'm going to multiply by 4i. So what I end up with is 20I over 16I squared. The I squared will become a negative 1. So instead of 16 times I squared, it's 16 times a negative 1, which is a negative 16. And then, of course, we would reduce this. So 16 and 20 are obviously both divisible by 4. So we would get 5I divided by negative 4, and that would be your answer. I want to look at one if there is a quantity. If there is a quantity, such as this problem, what you actually have to do in this case, just like we did with square roots, is you have to multiply by the conjugate. So instead of 1 minus 4I, the conjugate would be 1 plus 4I, which is what we would multiply by. So what we've got, if we look at this problem, is we have a binomial times a binomial in the top and the bottom, meaning we're going to have to FOIL this out. So I'm just going to take it piece by piece. I'm going to do the numerator first. 7 times 1 is 7. 7 times 4I is 28I. 5I times 1 is 5I. So I've got 28I and 5I giving me 33I. And then last but not least, 5I times 4I is 20I squared. I squared is a negative 1. That's actually a negative 20. So as I continue to simplify my numerator, I've got a negative 20 and a 7 that can go together, giving me a negative 13, and then I've got a 33I that I already put together. Now let's look at simplifying the denominator. Once again, we're going to have to multiply this out. 1 times 1 is 1. 1 times positive 4I is positive 4I. Negative 4I times 1 is negative 4I, and negative 4I times positive 4I is negative 16I squared. The positive 4I and the negative 4I will cancel each other out, and that I squared will become a negative 1, giving you 1 plus 16. Negative 16 times negative 1 is a positive 16. And 1 plus 16 is 17. Getting rid of the I in the bottom, which was the goal in the first place. And your answer then is negative 13 plus 33I divided by 17.